Hello, this is section 2.4, question number 23. We are asked to prove the statement using the epsilon delta definition of a limit. In this particular case, we have the situation of the limit as x approaches a of the function x equals a. I like to do these problems in two parts. Part 1 is the pre-work. And what we have to do is find a number delta such that if x minus a, its absolute value, is between 0 and delta, then we need to have the absolute value of f of x minus L is less than epsilon. If we start with the epsilon part, the f of x minus L, its absolute value, we do algebra to get to the delta part, comparing to x minus a, its absolute value, less than delta. Okay, start with the epsilon part, absolute value of f of x minus L. We substitute f of x, which is just x. We substitute L, which is a, and we get the absolute value of x minus a is less than epsilon. Well, that's the delta part. So, x minus a is less than delta. X minus a is less than delta. We have x minus a is less than epsilon. So this implies that we should try epsilon equal to delta. The second part, the actual proof. What we're going to do is show that our choice for delta actually works. We always write delta epsilon proofs the same way. We write proof. Then we write let epsilon be bigger than 0 with delta equaling whatever our choice is for delta. In this case, delta equals epsilon. Then we write if the absolute value of x minus a is between 0 and delta, then we must show the absolute value of f of x minus L is less than epsilon. Consider the absolute value of f of x minus L is equal to f of x was x, L was a, so that's equal to the absolute value of x minus a, and that is less than delta. X minus a is less than delta. Well, what's delta equal to? Epsilon. So what we have to show is the absolute value of f of x minus L is less than epsilon. Well, let's see. We have the absolute value of f of x minus L. That is less than epsilon. Therefore, by the definition of the limit as x approaches a of x is equal to a.